of circular economy and industrial symbiosis. So first of all, do we really need circular economy? Currently, around or more than 2 billion people are affected by water stress. Here you see a map, and the very dark red and the red are the areas where you have critical water stress and high water stress. Then in orange, you have medium water stress, and in yellow, you have low water stress. And this is the situation right now. And if you consider that climate change is progressing, this means also that our global water stress will increase. So this means we urgently need a plan B. And one part of this plan is the transition from a linear economy to a circular economy, not only in terms of water recovery, but also in terms of energy recovery. We can recover renewable energy and valuable material. So how does this work? Here you see this nice infographic. And in the middle of this infographic, where Nexus is written, this refers to wastewater, because wastewater has three resources. It has water, it contains material, and it carries energy. So this can be wastewater from municipalities or wastewater from industries like the food industry, beverage, or chemical biotech industry. And here, via certain technologies, we can gain fit-for-purpose water, which can be then reused for irrigation of agricultural fields, for public parks, for cooling processes, for steam production, or for cleaning. And I'm not going to talk about the technologies right now, because later on we will hear some examples for water recovery by Christos, Johan, and Nicoletta, as Cyprian already mentioned. Wastewater also contains different materials depending on the source of the wastewater. Usually it's nutrients like nitrogen, phosphorus, potassium, and can also contain sulfur. We have biomass in the wastewater, which can be then used for compost production, and it can also contain high added value compounds. What are these, and why is there high value? I brought here a table which was created by Dimitri, who will talk later on as well and give you more details about it, how to gain those high added value compounds. And what you can see here, that we have different compounds which can be really a treasure in our wastewater. But more details will be provided by Dimitri. Our wastewater also carries energy in the form of heat and in the form of biomass, which can be used to produce biogas. You can combine it, for example, with the digestion of organic waste. This is then called co-digestion. And from the biogas, you can also produce electricity and heat via a combined heat and power unit. And about biogas recovery, we will also hear a presentation later on, which will be done by Isam together with Dimitri. And they will talk about a case study in Israel from our project in Ultimate. So now you might think, okay, that's a nice concept for the circular economy, but how can I make sure that it will become a success? Our suggestion is find cooperation partners to create a win situation for everybody. So who might be those partners? It will be the one who produces the wastewater. It might be the one who has a demand for the products you will produce, and the one who's capable to operate the technologies. And if you have such a nice consortium, this is also called a symbiosis. So you have a cooperation between partners to create win-win situations. And this is also what we do in Ultimate. There we have 9 different symbioses between the industrial sector and service providers. So now you might think, yes, that's also nice, but which technologies can I apply? What does it cost? Are they environmentally friendly? And which legislative framework is necessary for the implementation of such a concept? And to answer all your questions, we are currently setting up a technology evidence base and a marketplace in our 3 projects, NextGen, Ultimate, and Be Water Smart. There are already, regarding the technologies, there are already fact sheets available. So you can go there, use the internet address you can see here, and you can get already information about the different technologies you can use. And the marketplace and also the case study section, they are still under development, but there you can also find information about the different assessments we will do in the projects, like the cost assessment, life cycle assessment, and so on. And we expect to have a first version with all the information beginning of next year. And now I would like to conclude my presentation. Here you see an example for a symbiosis between the agri-food industry and the water sector. This is one case study of our project in Ultimate. I'm not going to talk in detail about this infographic because we brought you a very nice movie, which we will show after my presentation, where this is explained in detail. But I would like to draw your attention to the different colors. So you see here the blue color for water recovery, the green color for nutrient recovery, and the yellow color for energy recovery. So we have here all 3 aspects of the circular economy. And with this, I would like to thank you for your attention, and I would like to ask the organizers to play the movie.
And now the movie.
The Netherlands is a hub for international production and trade of horticulture products. The horticulture sector is one of the largest exporters of fresh vegetables, cut flowers, and ornamental plants in the world, and is very efficient in water and fertilizer usage, producing more crops per unit area compared to many other countries. However, horticulture is also a major consumer of resources. For instance, one of the biggest crops produced in the Netherlands is tomato, with an estimated production of 2.5 million kilograms of tomato per day. This means that just for growing tomatoes, it requires about 500 million liters of water and 10 tons of fertilizer every day. The sector faces a number of challenges, including shortages in fresh water in the summer months and tightening legislation that prohibits discharge of nutrients or pesticides to the environment. In Ultimate, we investigate how the greenhouse system can be made even more sustainable by treatment of the wastewater so that water and nutrients can be reused, making safe reuse possible for human and plants, and the use of underground high temperature energy storage to reduce the need for fossil fuel for heating during winter. The work in case study 2 is focused on two aspects. Firstly, development of a water treatment solution based on electrodialysis for the selective separation of sodium from wastewater, allowing recycling of valuable resources. Secondly, demonstrating the feasibility of underground high temperature energy storage by linking up with a geothermal plant being realized for energy supply to horticulture in the Westland area. These solutions will be added to the portfolio of sustainable solutions available to the horticulture industry, such as aquifer storage and recovery, which were developed previously and are already used in our case study location at New Prinsenland. With these developments, Ultimate will add additional pieces to the puzzle of creating a circular and sustainable horticulture sector. And these solutions, of course, are not restricted to the Netherlands, but can be used internationally as well.
Thank you. Excellent, Anne, and I wish you all the best with your colleagues in all the cases. As you probably realize, dear, hi, Sam.
Hi.
It's fine. Everything is okay. Yes. Hi.
It is.
Nice to have you with us.